Hello my friends, let's continue our journey on IMO 2020. This is WebPig. The second problem is the following. We are given real numbers A, B, C, and D in a descending order, such that they sum up to 1. We are asked to prove the following inequality, that A plus 2B plus 3C plus 4D, the whole sum times the mounted power A to the A, B to the B, C to the C, and D to the D, is strictly smaller than 1. The problem looks a bit strange due to this mounted power, so the first step I do is to replace it by a nicer term. Let's see how I handle it. We first take log on this mounted power. By doing that, we have the power out and get the sum of A ln A, B ln B, C ln C, and D ln D. Notice that the second derivative of the function ln is minus 1 over x squared, which is negative. So the function ln is strictly concave. Now, using the fact that A, B, C, D sums up to 1, we are in a pretty decent shape to apply Jensen's inequality. This gives us the sum of A ln A, B ln B, C ln C, and D ln D is smaller than ln of the sum of squares. Finally, as ln is an increasing function, we obtain the mounted power is indeed smaller than the sum of squares. Next, we replace the mounted power by the sum of squares in the original inequality. It remains to show that the product of the term A plus 2B plus 3C plus 4D and the sum of squares is smaller than 1. Now the left-hand side is a degree-free polynomial in A, B, C, and D, so it is natural to perform a homogenization on the right-hand side. More concretely, as A, B, C, D sums up to 1, we can replace the right-hand side by the cube of the sum. Finally, we get something that we can brute force attack. Indeed, from the descending order, we have that A plus 2B plus 3C plus 4D is smaller than A plus 3B plus 3C plus 3D. This is again smaller than 3A plus B plus 3C plus 3D, and again smaller than 3A plus 3B plus C plus 3D, and finally 3A plus 3B plus 3C plus D. This implies that the first equation multiplied by the sum of squares is smaller than the sum of the second equation multiplied by A squared plus the third one multiplied by B squared plus the fourth one multiplied by C squared and plus the last one multiplied by D squared. So let's write it down. The second one multiplied by A squared, the third one by B squared, the fourth one by C squared, and the last one by D squared. Now we can simply expand the expression, and what it gives is the sum of cubes plus 3 times sum of A squared B. Well, this is strictly smaller than the same expression at 6 times the sum of ABC, which turns out to be the cube of the sum. Voila! This finishes the proof. I hope you enjoyed the solution. See you next time. Bye bye.